Okay, it's live. I want to make sure that everything is working on fine. Again. It's this slow, but at least it's connected here, and the quality of video is still, by over time, in time about it. It's not like it. Let me confirm that this one is still okay. Hey, it's connected personal last time. Okay. The purpose of this video is to solve the first seven questions posed by me in the 1 year with calculus challenge this year. I know that the challenge is not going as fast as, or it's not boosting. I thought the challenge would boost my channel, and all the challenge, no matter how the channel is going, but it's not really going channel because only one person is participating all this time. So I tell you that since too much participating, let me just solve the questions that I've said. Okay, so the previous I used to use PowerPoint to solve questions when I was in school, but I decided that since I have board now, let me solve them using the board. Maybe there'll be more explanation that I can go through as I'm using the board. But before I start, I want to just tell you that from now on, the questions will not be coming the way they've been coming. I've been putting too much effort, making sure that the questions are on all the platforms. But from now, all the questions will be posted. Guys, I'm still making adjusting the website, but they will all be posted on. Okay, this is. I wanted to make sure that this is working. I wanted to do it live, that live will be happening. I'm making happening on TikTok, but I don't think my internet is that strong. So maybe when I get to school, the school website, school internet will be stronger. So I'll do that in school. Yeah, I've connected on YouTube and connected here at the same time. But okay, the website is igwematics.blogspot.com. Right, for now, if you enter the website, the first thing you see, there is the homepage. The first thing you will see is just the beginning part, which says mathematics is structure. I can't even read it. I can't even read what I wrote. But I'll change the background to something else. That is the mathematics blocking what I wrote here. Then the next thing you see is a cat, which is the default for that website. But I'm going to enter this tab. Then if you click on competition, just beside home, the competition will light up and you will see the beginning of all the competitions that I'm going to host in mathematics. You can read all that. But then at some point in time, just below um I'll put it under all classes and under all ages, and also be in active competitions. So if you click any of those three places in those three slots, you will get to 1 year with calculus. That is OY with calculus. OYWC, you get to 1 year with calculus. And from 1 year with calculus, you can now click each of the weeks. You see other week 1, week 2, week 3 to week 50. I know we have 50 to 54 weeks, but the many 4 weeks, I'm going to leave that one aside. There will not be questions for that remaining 4 weeks. But then for the whole 50 weeks for this year, there will be question. So if I just click week 1, week 2, week 3, and you get the question. Then after that, that's where you get the questions. I'm not posting the questions again on my other platforms. Only on this website that you see the questions. Then the solution, I'll make the solution on YouTube, maybe to be on live or it will be pre-recorded. Then the solution you must see under the week 1, you see the link to the solution video. That's how the progress of this competition will go on, and that's how most of the other competitions and the whole will also go on. So this is the website, informatics.blogspot.com. Before I continue, I want to make sure that everything is still working fine. I feel the green light though because the video is dull. No, there's really not much difference. Okay, I will just begin. I don't think the lighting is right. I feel like the internet is stopping the video from being clear because the video was clearer when I was doing the previous live. But no other. I believe I've said something I wanted to see. The website, Ignorance of Blogspot. So let us begin. Week one. Week one asked us that we should find the derivative with respect to theta of the natural log of the cotangent of 4 theta squared minus 1. This question is packed. First of all, you have a function which is theta squared. You now have another function which is 4 theta squared. You now have another function which is 4 theta squared minus 1. You have another function which is cotangent. You have another function which is natural log. All inside this. And you are now found to differentiate. You are now told to differentiate it. Perform the following derivative. Here, cos 4 theta squared minus 1 is greater than 0. Now that's greater than 0 because now the natural log of a number, that is, cannot have the natural log of a negative number, which I still feel you can, because if you have minus 3, you know minus 3 to the power of, let's say, minus 3 to the power of minus 2. So you have minus 3 to the power of 3. Yes, you have minus 3 to the power of 3. This is equal to minus 27. So from natural log, we can get that 3 is equal to the natural log of minus 27 base minus 3. But I've not really seen anybody accepted this. But this is supposed to be true because the natural log of the logarithm now minus 3 to the power of 3 is equal to minus 27. So I believe there should be a form of negative logarithm where you have the log of minus 27 base minus 3 will give you positive 3. But that is not really accepted. I'm not seeing any place that they accepted for negative logarithm. So in that question, I just put it out there that okay, this cos 4 theta squared minus 1 must be greater than 0. So that the log will not have a negative number. So okay, still recording. So let me just make sure it's clear now. Let me check it's clear now. So I can move on confidently. Okay, still not clear. But if I rotate the video, it's still not clear. Okay, that's why it got a little bit clearer. Just a bit clearer. Let me check if I can get this one. Okay, outside here. Okay, that's why I got a bit clearer. So I don't know if the internet wala is going to affect what me I'm going to see. That means if it's going to affect what I'm going to see, that means you would have better internet, your own will be clear. But if it's affecting what is recording, then that means what is uploading to YouTube is going to be in 480 pixels, which is very low quality, so you may not see what's written on the board. So I pray that what the internet is affecting is the main phone, which does not seem logical because how is the phone that is giving this one hotspot the one that will not have the internet problem? So I'm very sure that it's this one that is recording to YouTube that will be in low quality. But one of the video things I'm getting here is actually a little bit clear. So I'm very sure I have a little bit confident that I can go on and you still understand the solution. So as to derive the natural log of all this with respect to theta, the first one want to just put out some. You can solve this any multiple ways. But one I want to use this substitution. Like this substitution is actually the best way to solve this. Without much stress. You can just use substitution and you get your correct answer. So the correct use of what I'm making now is let u equal to cos 4 theta squared minus 1 and let v equal to 4 theta squared minus 1. Good. These are two substitutions. This is use of this of, but they are just substitutions. You can use any letter you choose. You can use capital, use small u, you can use any letter you choose. So let u equal to cos 4 theta squared minus 1 and let v equal to 4 theta squared minus 1. So now use this u substitution to solve this. Now how do we use u substitution to solve this? Okay, before I continue, let me say let y equal to natural log of cos 4 theta squared minus 1. Now the reason why I say let y equal to all this here, so we can just say dy d theta. Like instead of saying the derivative of all this, you can just say dy d theta, you mean the same thing. So let y equal to all this here, let u equal to what's inside this bracket, and let v equal to what's inside the second bracket. That's basically what we're doing now. The reason why I did this is because you can apply something called the chain rule. The chain rule is very cool rule that if you have dy d theta, you can say dy let's say x1 times dx1 over dx2 times dx whatever amount of times you want. all the way down to the xn divided by the theta. So the idea is that, I know that most people, they don't agree with the fact that derivative can be used as a fraction, but the idea is that you have the x1 cancel out the x1, the x2 cancel out the x2 there, the x2 cancel out the x3 cancel out the x3, all the way to the xn that is one before here, we cancel out the xn here, and you be left to just the y, the theta is equal to the y theta. But it still applies even if you use first principle. If you use first principle, you still get this chain rule. So the chain rule that we also are going to use, since we already know the variables we are using, there's no need to use x1, x2. We already know the variables we are using. We have the y theta will equal to the y. Y is linked to, this is the natural log of u, so y is linked to u, so that is the y du times du dv times dv d theta. So this is this chain rule that we're going to use. Dy d theta is equal to dy dv times du dv times dv d theta. If there were anybody in the live, which I believe I'm the only person that is in the live right now, if there was any other person in the live, you should have asked your questions. But since everybody inside the live, I'll just continue, assuming that whoever watched the video later will be able to understand from here. So we have dy d theta is equal to dy du times du dv times dv d theta. So we now find what is dy du, we have to find what is du dv and what is dv d theta. And it's easy to find because you know the y is directly linked to u is directly linked to v, and v is directly linked to theta. If you look here, you have v is directly linked to theta here, you have u is equal to the cotangent of v, so it's directly linked, and y is equal to the natural log of u, so it's also directly linked. So you can find what the y du is, you can find out what the u dv is, and you can find out what the v d theta is. By the time you multiply them together, you get the y d theta, which is the main thing we're looking for. So I really don't know if we had a bigger board, it would be easier to solve. But since we are managing this, I don't know where to clean. Okay, you know what? I'm going to just solve it here, then replace this. So I will change it from y. Okay, let me see how this will work. Okay, let me apply it here. So since we said let y equal to natural log of cotangent of 4 square minus 1. Now what is the cotangent of 4 square minus 1? That is equal to u. Remember, we said let u equal to that. So we just basically have y is equal to the natural log of u. So just as you can see now, we said let y equal to this, and we said let u equal to this. But we now realize that what u is can be replaced with what y is. What, like something like inside y. So instead of y is equal to natural log of cotangent of 4 square minus 1, we just say y is equal to natural log of u. Because u is equal to cotangent of 4 square minus 1. So now we have y is equal to natural log of u. Now if we differentiate, that we find y du, we realize that this is just equal to 1 over u. You already know how to differentiate a natural log of u is equal to 1 over u. And that is because if you integrate 1 over u, you will get the natural log of u. So instead of the y du here, we replace it with what? 1 over u. Instead of the y du here, replace it with 1 over u. The next thing now is du dv. Let me clean this. I hope you are following. I hope you are following. I'm doing this at live. This board that I clean, and I wish I'm still in school because the board in school was a lot bigger. I could do a lot of things. But okay, the next now we have u. We have to find the u dv. U now is directly linked to v. How is u directly linked to v? There's no v inside this formula. But how is u directly linked to v? You can see that here you have 4 theta square minus 1. Here you have 4 theta square minus 1. But this 4 theta square minus 1 is equal to what? This 4 theta square is equal to v. So basically this u is not equal to, or is equal to this, but then it's also equal to the cotangent of u. Sorry, the cotangent of v. So we have u is equal to cotangent of v. So now if you differentiate cotangent of v, what do you get? Now, it's not all derivatives that have offheads. The same way natural log of u. I just immediately told that natural log of u, by the time you derive it, you get 1 over u. But it's not all derivatives that have offheads. So some of them I used to derive them right here in the example, right here when I'm doing the test. So to derive the cotangent of v, we have to know that the cotangent of v is equal to 1 over tan. I know tan is equal to tan over cos. That's sin b over cos v. So 1 over tan v is going to equal to cos b over sin b. So u is equal to cotangent of v, and that cotangent of v is equal to cos b over sin b. Okay, cos b over sin b is not really showing on the screen very well, but you have cos b here, that is the cosine of v, and and you have sine v here, which is the sine of v, your normal trig functions. So now if you have to differentiate this now, what you're going to apply here is the quotient rule. But there's not really more space on the board for me to show you the quotient rule. But let me just try the quotient rule here. If you have something like du over v is going to equal to v du minus u dv over v squared. So first of all, you square the denominator and put as denominator. Then you find the derivative of the denominator, then times it by the du dv minus you carry du times it by the derivative of the denominator. That's what we're going to do here. So now u is equal to all this. That means du dv should equal to, first of all, you square the denominator. So that's equal to sine square v. Then you multiply the denominator, which is sine v, times the derivative of the numerator. The numerator is cos v. If you derive cos v, you will get minus sine v. So you have here minus sine square v. The denominator now is sine v. So you have minus sine v times, minus u, which is the numerator. So you have cos v here. Minus cos v. The denominator now, you now derive the numerator. So now you have cos v. So you have minus sine square v minus cos square v divided by sine square v. Now, from your trig functions, you know sine square x plus cos square x is equal to 1. So you have minus sine square x minus cos square x, you get minus 1. So all this up here, this minus sine square v minus cos square v is all equal to minus 1. In the next solution, in the next question, I'm going to actually minimize my space. Instead of writing all these things big, you are not really planning for all this. Okay. So now instead of writing all this, you have just minus 1 here. So now all you are left is minus 1 divided by sine square v. So you know that the du dv, which is what you are looking for here, du dv is equal to minus 1 divided by sine square v. Sorry. So all this here is equal to minus 1 divided by sine square v. So now the last one that we're looking for now is dv theta. Remember, I thought that divide theta is equal to divide du times du dv times dv theta. So what we're looking for was what divide u and du dv was. Now that one is dv theta. So now what is dv theta? First of all, what is v with respect to theta? V is equal to 4 theta squared minus 1. V is equal to 4 theta squared minus 1. So then this one is going to be the easiest one to derive. Actually, no, the easiest one to derive was y is equal to u. So that one I just said that is going to be equal to 1 over u. So now if we differentiate v with respect to theta, all you are left with is, first of all, you bring out this square, bring it down. So you have 4 times 2, which is 8, times theta to the power of 2 minus 1, which is 1. So you have 8 theta. That is, you know how to derive already now. Let me clean this. So if I differentiate, let's say you are differentiating something like ax to the power of n. Yes. If I differentiate x to the power of n, we rated x. This is equal to a times n times x to the power of n minus 1. So you bring out the power, then the power up there will like be subtracted, you subtract 1 from it. So you bring out power 4 times 2 times theta to the power of 2 minus 1. Theta to the power of 2 minus 1 equals to theta to the power of 1, which is equal to theta. So I just have to 3 times theta. For the 1 here now, remember that 1 is not just 1 here. 1 is 1 times x, is theta. 1 times theta to the power of 0, because theta to the power of 0 is 1. So if you are bringing down this power, you are left with 1 times 0 times theta to the power of minus 1. 0 times anything is 0, so all these just turns to 0. So this is just 8 theta plus 0. But there's no need to write plus 0, so I just have 8 theta. So dv theta is equal to 8 theta. So now I've differentiated the three of them. We have 1 over u times minus 1 over sine square v times 8 theta. But now this is not just our answer, because remember, it is us who say let u equal to this. It's us who say let b equal to this. The question is not saying anything like u is equal to this, b equals to this. It's us that said let this be equal to this. So if we are still seeing the thing inside the solution here, we have to backward substitute. That's not about substitution. The moment you substitute, you have to resubstitute. Guys, take that thing I substituted out of here. If you notice, even in simultaneous equations, the moment you say let this equal to this, or you do let b equal to all this, you have to also do the reverse to get back to your initial variables. So now we have u here, we have v here. Now what is u? Let me okay. 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 I don't really know where to clean now. Okay, I'll write it down here, then transfer it. So now we have 1 over u, we'll use equal to cot 4 theta squared. So we write it there. So we have cot 4 theta squared minus 1. Now what is v? V is equal to 4 theta squared minus 1. So instead of sine square v, we have sine square 4 theta squared minus 1. And don't forget, I know that nobody has joined live yet. Oh, I'll just say when people join live. So now nobody has joined, but I'll just say when people join live. I want to just say that I'm still saying it. I just say I'm going to say it after people join live, but I'm just going to say it. I'm going to do YX question, guys. I found a past question online. It's very hard to find past question. I've been looking for past question, original one. But it's very hard. But I found past question online, and I think it was 2011. So we're going to solve that. In case any of you have YX past question, please send them to my DM and I want to solve that before I get back to school. So we have based on 1 over u, we put in the value of u here, which is cot 4 theta squared minus 1. And instead of minus 1 over sine squared v, we put in the value of v, which is 4 theta squared minus 1. And now we have this. So now, since we have substituted back, there's no need for all these long talk here. I can clean them all out now. There's no need for all this. I can just clean them all out so that there will be space. Okay. Now, what is 1 over cot 4 theta squared minus 1? Remember, I told you from the beginning that 1 over cot, sorry, I told you that cot on its own is equal to 1 over tan. If you find figures of two sides, you have tan is equal to 1 over cot. So then now you have 1 over cot, that is just equal to tan 4 theta squared minus 1. But what is now tan 4 theta squared minus 1? Tan 4 theta squared minus 1 is the same thing as sine 4 theta squared minus 1 divided by cos 4 theta squared minus 1. So instead of having tan x, you can separate it into sine x over cos x. So instead of having 1 over cos 4 theta squared minus 1, I said that is equal to tan 4 theta squared minus 1. And that tan 4 theta squared minus 1 is equal to sine 4 theta squared minus 1 divided by cos 4 theta squared minus 1. So now we have times minus 1 over sine square 4 theta squared minus 1 times what? 8 theta. That being said, I believe I can now clean all this here, except if you want to write it down. So you can write it down. But yeah, the video is still going. So I can now clean all this here. So now we're left with this. Sine 4, you can see the marker have changed from black to green. I mistakenly, like the black marker was still working. But I don't know what ended in my head. They told me to wait till the black marker finish, I put the green marker. I went over myself and I went to put the green marker on top. So the green marker now, since it's fresh in, overpowered the black marker. So the green just went down immediately and the black just faded out. Now the marker that is now from black now become green. So now we have all this here, but we still need to simplify. If you notice here, we have sine and we have sine squared here of the same thing. So instead of having x divided by x squared, why not just cancel x from both sides? So now instead of having sine this divided by sine squared this, just cancel out one sine from here and cancel out one from here. Remember, we had x divided by x squared. You cancel out one x from here, you cancel out one power from here, so you are left 1 over x. So now here we have sine 4 theta squared minus 1 divided by sine square 4 theta squared minus 1. You cancel out one of the signs, cancel out one of the other one. Now you are left with minus 1 over sine 4 theta squared minus 1. But this is not all. Let me write this down. But this is not all. Remember, we still have cos here. And remember, we still have 8 theta here. So now we multiply, we have cos 4 theta squared minus 1. And remember, this 8 theta, so we have 8 theta. Let me check how long I used to solve this question. So guys, that was around 24 minutes to solve this question. So yeah, there's probably that means I can estimate that to solve the whole 8 questions, the whole 7 questions take about 2 hours 30 minutes plus or plus. Yeah, a lot of plus because the main question I don't harder than this one. Now I left minus 8 theta. I'm not going to do this question. I left minus 8 theta divided by sine 4 theta squared minus 1 times cos 4 theta squared minus 1. This is a very good answer. That is, the person that solved this question actually got this particular answer. This is a very good answer. But I went further to use some identities. Let me clean this up. I went further to use some identities to further simplify. Remember that sine, you know your double angle, we have sine A plus B is equal to sine A cos B plus cos A sine B. If you let B equals A, then you have sine A plus A, which is equal to sine 2A is equal to sine A cos A plus cos A sine A. Sine A cos A plus cos A sine A is same thing as 2 times sine A cos A. So if you look at this now, we have sine here times cos here. We have sine here times cos here. So this should remind you that if we multiply both sides by 2 over 2, here will become 16, and here will be 2 times. Now we have the same thing. We have 2 here, 2 here. We have sine here, we have sine here, we have cos here, we have cos here. So all this simplifies to sine 2a. So all this can come out. All this blah 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 here. No, I shall not do that. I haven't written by side, but no other. All this can come out. Our left is sine 2 times 4 theta square minus 1, which is something as 8 theta square minus 2. Yeah. So now this is the second solution, which I feel is more compact, more squished. Because we at least more squished together, more simplified. You have minus 9 theta divided by sine 8 theta square minus 2, which I feel more simplified than the other one. So you have that solution, the first one I showed you, and we have this solution. They are both absolutely correct. And in fact, in the picture solution, I think I wrote down here. Let me check if I still on my phone. But I think I wrote down here like a lot of. I think I do up to 5 representing this answer. Let me check if I still have the picture solution. Screenshot, Telegram, Twitter, wallpaper. Okay, yes, I still have the picture solution. So in that place, I wrote down, okay, there are 3 different solutions that I wrote down, which I still say that, and many other variations, but only a few well simplified variations will be accepted for grading. So we have the derivative of order equal to minus 8 theta. Okay, the first solution I put there was in the form of, instead of 1 over sine, I put it there as cosec and sec. So the first one there is minus 8 theta times cosec, 4 theta square minus 1 times sec, 4 theta square minus 1. The second solution I put there was minus 16 theta times cosec, bracket open. That is, instead of sine here, you just put it as cosec 8 theta square minus 2. A third solution I put here was minus 16 theta divided by sine 8 theta square minus 2. Same thing as that. Then the fourth solution I put here was, the first solution that I got was minus 8 theta divided by sine 4 theta square times cos 4 theta square. There are plenty other ways you can represent it. Trigonometry. There are plenty different ways you can represent it. There are many different ways you can represent it. So yeah, that's the end of week 1. That's the end of the one solution. I would go on now to solve the second question. Let me get it. I can't really remember the question. Okay. Off heart. Is it off heart or off head? I don't know, but I can't remember the question. One you cut over. Okay, yeah. Okay, with 2 solutions, with 2 questions, sorry. With 2 questions was more than 2 questions because of even in the group that I made, that is WhatsApp group that I made, somebody asked me a question to solve an integral, and we ended up getting 2 different answers. That is, his own answer was in one form. My own answer had something at the ending. It had a number at the ending. I can't remember the number, but let's call it S1 plus a constant. His own solution did not have this number at the ending. His own solution just had that plus constant. That there's a reason why his own had that only plus constant. My own had a number, and he didn't really get on with the solution. And this question, if you calculated in this one year calculus, we would have seen that this type of thing formed in this one year calculus, this solution. The question asks us that we should perform an integral. That is, what's the integral of 2 minus 3x all squared dx. So now, imagine actually this question, instead of this, actually what's the integral of 4 minus 12x plus 9x squared. If I ask what's the integral of this now, you would have given me a totally different answer than using this, even though 2 minus 3x is the same thing as 4 minus 12x plus 9x squared. And that's what happened with that person's question that he asked me. He asked me the question in this form. One way I did was to simplify it to this form, and then I got my answer. But him, he just went through this method, and then he just got it without getting this thing, without getting a number, which is x1, let's say x1, and the constant. Him just got directly plus c. But me, I got a number and the constant. So that is really just the battle with this. But no matter which method you get, I still showed a form of way of reasoning, because that is part of the part 3 of the question. Part 3 of the question asks you compare your results from A and B and explain the reason why they are a little bit different, even though they're the same thing. So let us start with it. The question asks us perform the following integral as instructed in each part below. Part A, let's start with A. Multiply 2 minus 3x squared. Now, multiply 2 minus 3x by itself and integrate each term separately. Let's do that. Multiply 2 minus 3x by itself and integrate separately. So first of all, we know 2 minus 3x all squared is equal to 2 minus 3x times 2 minus 3x. And the way to expand this, you have 2 times the first bracket, the second bracket, sorry, 2 minus 3x minus 3x times 2 minus 3x. So we have 2 times 2 minus 3x, that is 4 minus 6x. You have minus 3x times 2 minus 3x, that is minus 6x plus 9x squared. So all you know, we have 2 minus 3x all squared is equal to 4 minus 6x, sorry, 4 minus 12x plus 9x squared. So we have 4 minus 12x plus 9x squared equal to 2 minus 3x all squared. So now the question says that we should expand that bracket and then integrate each term. So I just find integral of 2 minus 3x all squared is equal to integral of 4 minus 12x plus 9x squared dx. Sorry, this is dx here. Respect x. So if you integrate the first term, you have 4 dx. Sorry, the integral of 4 dx, which is just 4x. If you integrate the second term, you have minus 12x. The integral of that, you have minus 12x squared over 2, which is just minus 6x squared. Which is just minus 6x squared. The next one now you have plus 9x squared over 3, which is just plus 3x cubed. So remember your integral. If you have the integral of let's say ax power of n is equal to a divided by n times x. So a divided by x plus 1. Sorry, a divided by n plus 1, not x plus 1. A divided by n plus 1 x times x power of n plus 1. So you increase the powers and then divide by that increment of power. So here you have 4 minus 12x plus 9x squared will equal to 4x minus 6x squared plus 3x cubed. Don't forget your integral constant plus k. So this will be your answer. You have the integral of 2 minus 3x all squared dx is equal to 4x minus 6x squared plus 3x cubed plus k. This k will cancel if you differentiate. So that just put the k because it's an indefinite integral. That is the upper bound and the lower bound are not specified. So these are indefinite integral. So that k does not cancel out. So you leave the k there. The second thing that, let me write down this solution here. 4x minus 6x squared plus 3x cubed plus k. The second thing that asks us to find is that is they say we should use another method entirely and check what solution will give us. The second method they say we should use is use substitution. I still remember that. But let me just get down the correct thing. Option or rather part B. Yes. They said integrate using the method of use substitution with u equal to 2 minus 3x. Like they already give us use of the value of u that we should use. And that was actually the correct value of u you should use. There's some use that you use that you make your work harder. There's some use that you use that will make your work easier. And this will make your work easier. You have u is equal to 2 minus 3x. So if you substitute this into here, you have the integral of 2 minus 3x all squared is equal to the integral of u squared. Because now u, sorry, dx. Because now u is equal to 2 minus 3x. But the problem with this is that you are differentiating u with respect to x. So you are integrating u with respect to x. You can differentiate u with respect to x, but you cannot integrate u with respect to x. So we have to integrate u with respect to u. So we have to find what we replace, what we replace this dx here. And remember from here, u equals to 2 minus 3x. We can get that the derivative of u with respect to x is equal to, if you differentiate 2, you get 0, is a constant. If you differentiate minus 3x, you get minus 3. So the u dx is equal to minus 3. If you multiply both sides, because multiply, this will imply that dx is equal to du divided by minus 3. So this dx here, which you are seeing here, you can replace it with du divided by minus 3. And that's what we're going to do now. This dx here, we replace it with du divided by minus 3. But I don't really like negative, so I'm going to just move this negative here. So you have 1 divided by minus 3 here, and this is just du. So if you integrate u squared with respect to u, you get u cubed divided by 3. Don't forget to multiply by minus 1 over 3. This is minus 1 over 3 right here. Don't forget to multiply by that again. You have u cubed divided by 3 plus your integral constant. Let's call that cube. So you have minus 1 over 3 times u cubed divided by 3. This is just going to be u cubed divided by minus u cubed divided by 9. Minus u cubed divided by 9. Okay. Minus u cubed divided by 9. So now what is u cubed? Remember that u is equal to 2 minus 3x. So u squared is equal to, as we've done before, is equal to 4 minus 12x plus 9x squared. And u cubed is equal to 2 minus 3x times this, which is 8 minus 24x plus 18x squared minus 12x plus 36x squared minus 27x cubed. You can go ahead to confirm this using your just multiply. You can pause the video and multiply by yourself, but I don't really have time to multiply to waste time multiplying. But now you have 8 minus 36x plus 36 plus 18, that is going to be around 40, 46. Oh, that's going to be around 40, 48, 48x squared minus 27x cubed. No. 36 plus 18. 14. So it's going to be 54, not 48. 54. So you have 54 x squared here. So all this u cubed is equal to all this. But remember, I know how to find u cubed. I have to find u cubed minus u cubed divided by 9. So you find the negative of all this. So just put minus here, all the minus, all the places you see plus, put minus, all the places you see minus, you put plus. So we have minus 8 plus 36x minus 54x squared plus 27x cubed. Don't forget to divide by 9. So this is equal to, minus 8 over 9 plus 36x divided by 4, that's 4x. Minus 54x squared divided by 9, that is minus 6x squared. 27x cubed divided by 9, that is plus 3x cubed. Don't forget to plus k. So now you have minus 8 over 9 plus 4x minus 6x squared plus 3x cubed plus k. That is the solution to part B. Now part C now asks you, compare your results from, compare your results from A and B. Explain the reason for the difference. If you compare your results from A, this is part B. If you compare your results, say there's 4x here, 4x here, then minus 6x squared here, minus 6x squared. There's plus 3x cubed here, there's plus 3x, there's k here, there's k here. But where did this minus 8 over 9 come from? So now, you say compare your results and explain the reason for the difference. Now, the reason for the difference is that there's actually no difference between these two. If I end up saying that let this k not be k, let this k be c, and I say let k equal to minus 8 over 9 plus c, then this minus 8 over 9 plus c, which is this minus 8 over 9 here plus this c, we simply just don't turn to plus k. Just turn to plus k, and you get the exact same result that you got here. But that minus 8 plus 9, just minus 8 over 9, just really just appeared because of the method you used to solve. That appeared because of the method you used to solve. So no matter what, even if let us say you are asked, an indefinite, so a definite integral. You know, a definite integral, there's no need for add constant. So now that minus 8 over 9 may look as a problem. But the reason why it does not actually pose a problem to the integral is because of, at the end of the day, that minus 8 over 9 will cancel out itself. all constants get cancelled out when you have once you have a definite integral. And once you have an indefinite integral, you can just add all the constants. That means 8 over 9, even though you are not saying that's a letter, even though it's not a letter, it's still a constant, it does not change, no matter what the value of x is. That means 8 over 9 will remain minus 8 over 9. So just add all the constants together as plus k. So it does not really change the question. But let me just check the exact words I used, because for the words I used for this one, I really went deep into using correct words. I don't just say assume that it's no, I use actual words. So, yes, based on the method you use. There's no reason why that appears, just appears based on the method you use. Okay, this doesn't change the fact that they are the same. Why? Because 8 over 9 is still constant and can be merged with the previous constant to form C, making the two expressions equivalent. So I just leave just same. Let's go to the next question. So yeah, that brings us end of this with two questions. That brings us end of 2. I believe I said everything I wanted to say under this. They already give us the method we should use. They don't really give us the question and say find integral of this, find divide this. They give us the method that they want us to use. So let me move on to the next question. Why you calculus? So we have a true question. True question is actually a very big one. Not really that big, but a lot of people complain about it. But you have the derivative. We should find the eighth derivative with respect to x of x to the power of 10 divided by 10 factorial minus x to the power of 9 divided by 9 factorial plus x to the power of 8 divided by 8 factorial minus x to the power of 7 divided by 7 factorial. I don't really know what this question hears most people, because you can just really just differentiate this 8 times and you get your correct answer. But that method will actually be time consuming. Why differentiate 8 times when you can just find the pattern? But for this video, I've already explained all the patterns that you can find in the other social video that I use PowerPoint to explain. But this one I'm just really going to, because I'm going to differentiate. I'll differentiate 2 times. Or I don't know if I was differentiate the whole 8 times. So I want to make sure that I explain everything deeply, but I'll just show you the pattern that we merge if we differentiate one by one. So let's do this. Let y equals all this. I don't write it again, but let's y equals all this here. Then all we're finding is the derivative of y. All we're finding is the derivative of y with respect to x. So first of all, let's find the first derivative, the y, the x. If we differentiate this one time, the first thing you notice that this power here will come down. So you have 10 x to the power of 9. Or let me do step by step. We have 10x power of 10 minus 1. 10x to the power of 10 minus 1, yes, times divided by 10 factorial minus 9x to the power of 9 minus 1 divided by 9 factorial. I'm not going to write 9 yet because the power of 9 comes down, plus 8x to the power of 8 minus 1 divided by 8 factorial minus 7x to the power of 7 minus 1 divided by 7 factorial. So now, what happens to the power? 10 minus 1 becomes 9. 9 minus 1 becomes 8. 8 minus 1 becomes 7. And 7 minus 1 becomes 6. What happens to what do you call this coefficient? This 10 here will cancel out 10. You know that 10 factorial is equal to 10 times 9 factorial. You know 9 factorial is equal to 9 times 8 factorial. You know 8 factorial is equal to 8 times 7 factorial. You know 7 factorial is equal to 7 times 6 factorial. So this 10 here will cancel out 10 here, leaving you with x power of 9 divided by 9 factorial. This 9 here will cancel out 9 here, leaving you with x power of 8 divided by 8 factorial. This 8 here will cancel out 8 here, leaving you with x power of 7 divided by 7 factorial. And this 7 will cancel out 7 here, leaving you with x power of 6 divided by 6 factorial. Let me clean the board up. So we can say that the first derivative of y with respect to x, that is y dx, is simply just x to the power of 9 divided by 9 factorial minus x to the power of 8 divided by 8 factorial plus x to the power of 7 divided by 7 factorial minus x to the power of 6 divided by 6 factorial. This is simply what it is. And already, immediately I've already seen the pattern that will show. But in case you cannot see the pattern, let's differentiate again. So this is the first derivative. Now some people will be confused that, okay, why did they pick that notation for the second derivative? Second derivative, because we are differentiating, that is differentiating the y dx. You know that the x dx comes to multiply each other here and I have the x squared, and d times this d times d times y is just d square y. That is basically why that notation was split. So you have d square y divided by the x squared. That is basically why that notation was split. So now we're finding the second derivative, d square y divided by dx squared, and that's equal to the first. Everything happens again. This 9 comes down here. You have 9x to the power of 9 minus 1 divided by 9 factorial minus x to the power of 8x power of 8 minus 1 divided by 8 factorial plus 7x to the power of 7 minus 1 divided by 7 factorial minus 6x to the power of 6 minus 1 divided by 6 factorial. Since you have 9 minus 1, that is 8. 8 minus 1, that is 7. 7 minus 1, that is 6. 6 minus 1, that is 5. 9 divided by 9 factorial, that is going to be 1 divided by 8 factorial here. And this 8 becomes 7 factorial. This 7 factorial becomes 6 factorial. And this 6 factorial becomes 5 factorial for the exact same reason. So now you have 8 x power of 8 divided by 8 factorial minus x power of 7 divided by 7 factorial plus x power of 6 divided by 6 factorial minus x power of 5 divided by 5 factorial. If you've not seen the pattern, then I don't really know what's wrong with you, but if you notice, this was 10 here, you move to 9, you move to 8. 10, 10, 9, 9, 8, 8, 9, 9, 8, 7, 8, 8, 7, 7, 8, 8, 7, 7, 6, 6, 7, 7, 6, 6, 5, 5. So everything all the way down to when the terms start cancelling out. Because eventually, once you derive something number of times, it will discuss except for e to the power of x. E to the power of x does not get cancelled out. E to the power of x remains itself, and negative derivative, that is x power of minus 1. You can continue deriving it till infinity. E to the power of x remains the same, while every other thing positive, let's say x power of n, it all ends. So x power of n positive polynomials all end. E to the power of x remains the same, while negative polynomials tend to infinity. You can continue deriving them continuously. You have to infinity. So these are just two things. For this one, you have all positive powers. All positive powers. 10, 9, 8, 7. So it all keeps deriving to the point when you cancel out, and at the point it just all becomes, they all just become 0. So if you have to find the third derivative, there's no need to do any more solving. Just reduce the power by 1. You have x power 7 divided by 7 factorial minus x power 6 divided by 6 factorial plus x power 5 divided by 5 factorial minus x power 4 divided by 4 factorial. There's no need solving. But I don't want to specify a very, like, it's the formula that I used for the other video. As you are doing this, if you notice, the power here is 1 and this reduced by 1. The power here is 3 and all this reduced by 3. So you are finding the nth derivative, that is d ny divided by dxn. This will equal to all the powers here, removing all the numbers here, reducing them by n. So you have 10. If you have this the power of, if I look for the third derivative, just minus 3 from all the numbers that are here. So if I look for now, you also have to find what the 8th derivative. Because we have to find 8th derivative, just minus 8 from all the powers that are here. Let's do that. Minus 8 from all the powers that are here, you have x to the power of 2 divided by 2 factorial minus 8 from here, you have x power of 1 divided by 1 factorial plus minus 8 from here, you have x power of 0 divided by 0 factorial. X power of 0 is 1 and 0 factorial is 1. So this 1 divided by 1, that's just 1. And here you have minus x power of 7 minus 8, that's minus 1 divided by minus 1 factorial. Now all negative factorials lead to 0. So all this here becomes 0. So all this here becomes 0. We know 0 factorial is equal to 1. And 0 factorial is equal to 0 times 1 minus 1 factorial. So that minus 1 factorial, 1 divided by that minus 1 factorial is just going to equal to 0. As you divide both sides by minus 1 factorial, you have minus 1 factorial here cancelled out. And here you have minus 1 factorial. So 1 divided by minus 1 factorial is just going to equal to 0. So all this here is just equal to 0. Now you are left with x squared divided by 2 minus x plus 1. So this is going to be your 8th derivative. The 8y over dx is, they are looking for just equal to x squared over 2 minus x plus 1. I believe that brings us to the end of this solution. This is for recording. Okay, still recording. I believe that brings us to the end of this week 3. I don't know if, let me check if I said anything important in the future solution. in pictures I knew, I just asked, in pictures I during this entry, in fact, in pictures I saw for the 7th derivative before I saw for the 8th what to choose for. You can divide it all the way down to 8th derivative if you choose, but to find out what the 8th derivative is. Straightforward. X squared divided by 2 minus x plus 1. So now let's move on to the next week. That's week 4. I believe that means we already have halfway through this video. So all things being equal, I will do the YX solution. Actually, jam started closer than YX, but no matter what, I don't really know how to get jam position. So I would have to use the YX position I have. These are to get YX position to get jam position. So now the next question here, we have to find an integral. This is week 4. So we have the integral of the x divided by the square root of 3x plus 4. Okay, depending on it's turning back black, which is quite confusing. Why it turn from black to green back to black, but well, let me confirm that you are still sorry. Let me confirm that you are still clear. No, no, I thought I was supposed to work on this. Okay, I believe let me continue here. Let's recording. Okay, we have five integral of this year. Now, to avoid confusion, some people may be confused why is DX here. This is as DX here. I don't know. People, mathematicians, we hate when they use DX, guys, and calculus as fractions. Calculus is not fraction. Don't say that dy over dx is equal to dy times 1 over dx. Me personally, I'll strangle you. But yeah, I'm basically doing the same thing here. But yeah, it's all allowed. This dx here can be here. I can also put it here. Same thing. But okay, but find the integral of 1 divided by the square root of 3x plus 4 dx. Now I don't really know because most of the methods, that if here was square, let's say it was square root of 3x squared plus 4. And I'll begin to look at our trigonometric functions. There is sine square theta plus cos square theta is equal to 1. There is divided by cos theta, we have tan square theta is equal to 1 over cos, that is sec square theta plus 1. So I'll begin to look at a way of using this by saying something like let x equal to sec square theta or something like that to make sure that this here we turn to just tan. So you have 1 over tan, that is cos. But in this case now, this is not what we're giving. We're just giving square root of 3x plus 4. So I don't know, I bet it's going to be easier to solve. But no matter what, I'm not telling that in case here was 3x squared plus 4, there's still a method of using that is substituting your two functions. But two functions will give you a more easier answer. So now you have 1 divided by the square root of 3x plus 4. The first one to do is use substitution, which I believe is the easier. I don't use the word the only way because calculus is very broad and integral on its own is more bigger than differentiation. I don't say that this is the only way, but this is the easiest way I can do. So we have let u equal to 3x plus 4. If we say let u equal to 3x plus 4, if I want to do two integrals, I want to check. I want to use this integral, this u sub. And I want to use u sub for let u equal to square root of 3x plus 4. I want to see how the two of them work out. Let equal to 3x plus 4 is the first one I'm going to use, which is the one that gave my solution that I put here as special solution. That's what I'm going to use in this solution too. So if we differentiate both sides, we have du dx is equal to 3. Plus 4 gets cancelled out, but you have 3x here. So if you differentiate 3x, you get 3. So if we write this now as the integral of 1 divided by the square root of u. Remember that you have u equals 3x plus 4. You have square root of 3x plus 4 here. So this just equals square root of u dx. But what's that dx now? This u dx equals 3. That means dx is equal to du over 3. So instead of x here, we put du divided by 3. This divided by 3 can come out here as 1 divided by 3. I don't really know. You don't like doing this thing, talking. But if you specify that you are that you are this thing, what do you call it, secondary school that are watching, I will do this thing. After this, the university friends that I have that are watching. If it's the university people, then there's no need for me to do the work question for them. So, but I will continue with this one until I finish. But I'll do the like Lawrence. God bless you. Why did you go to my TikTok page? But this thing, I will do the live. I'll start another live in TikTok just to see how TikTok live works after this live. No, I don't want to make sure I'm good, conversant with all the lives. Then also check Facebook to see how Facebook works too. So you have instead of the use over three, you put the 1/3 outside. You can leave it inside the fridge, yes, it's light. Does fan work? Because I'm like, okay, you have low comment bar. Yes. Yeah, it's still low, it's still low. Oh, no, it's after telling. No, it's still low. Because that light is not cool, it's still low. Okay, so now we have the integral of wait, was I supposed to say that we have low comment? But now of course the pay for light is the government that is not giving us light. So we have u divided by u square of u now is going to be u power of 1/2. It's easier to change all these things to indices form. Easier to change them indices form. Not really. It's also right that the government is not working. I mean, they don't concern. Well, we have u power of 1/2. U power of 1/2 is root u. Instead of root u, you just put u power of 1/2. So now that I have 1/root u, you can actually change it to u to the power of -1/2. Because when you have 1/this, it turns to this to the power of -1, and you have square of root of this, it turns to this to the power of 1/that root. So now you have all this here. Now what's the integral of u to the power of -1/2? Just like I've been doing the previous solutions. You have first of all you have u. First of all you have the coefficient. The coefficient here is the coefficient is supposed to be 1/3, but it's already outside, so there's no need to add it again. You still multiply. So you have the coefficient here times u to the power of -1/2 plus 1 divided by -1/2 plus 1 plus your constant. Don't forget to multiply again by that coefficient. So even if you bring it out or you leave it inside, that multiplication sign will still merge them together again after, sorry for clapping, but still merge them together again after you perform the integral. So now what is -1/2 plus 1? It's just going to be 1/2. What's 1/? I just answered because you have 1/2. 1/2 if you flip it, you get times 2. So this just times 2 here. And now what is root to the power of half? That's just square root of u. So we have 2/3 times the square root of u plus k. But don't forget that our answer is not supposed to be given in terms of u. I thought that once you substitute the first one, you have to substitute again. So you have u be cleaned out, and you are going to put back that 3x plus 4. So the solution to this question is going to be 2/3 times root 3x plus 4 plus your integral constant. Let me cross-check our solution that we got in the previous solution in case I said anything different. Like in case I said anything important, what is keynotes, I can explain them now. Because in this solution, I make sure I put a lot of keynotes in them. Some of them could not enter through, so I erased them at the end of the day. But most of them, I put some keynotes, all these shortcuts, and the rest. So this one does actually also just a straight integral. So I put 2/3 times root 3x plus 4. Oh my god! Oh my god! In the final solution, I forgot to put the integral constant. I put it here as I don't know if it's showing, but I put it here. You can see the plus, see that I put here. But in final, in this when I put them in a square bracket, so at least the final answer, I totally forgot to put the integral constant. But yeah, the integral constant is supposed to be there after the differentiate. That is a very big problem. Sorry, that's a very big problem in most calculus exams. You hurry up to solve. I don't know, not forget to put your integral constant. Just like you're solving vector questions, you hurry up to find the magnitude of the vector, magnitude of the vector. You now forget the direction of the vector. I don't think you've totally failed the question because it's like I'm beginning on you like me now. Let me not say I don't really mind if you don't forget your integral constant because most of the times in real life application we're solving using this what they call it. What do you call this in the game? Direct, no. Oh, I said this like 2 times in this video. I've forgotten so quickly. Definite. Most of the time we're solving using definite integral, where you have the upper limit and the lower limit. In fact, let me give you a quick peek or a sneak to your final solution. This is question 50. The question is going to come out on my birthday. So this year, I just actually the best day for me to have done this thing. So it's going to come out on December 12th. I'm going to finish on the 18th of December. It's for my own brother's birthday. So this integral question, just a quick peek. I don't know if it's sure, but yeah, that's quick. I don't, you can also question before the question comes out. But yeah, this question says is a definite integral. I'll give you a hint, but that hint will actually expose the question. But is the Gaussian integral. The Gaussian integral is one of the rarest integrals that you cannot use your normal methods. So I actually just implanted this thing, some variables around integral. And I want to see how you can apply Gaussian thinking to solve more. Because the only one he solved there was e power of minus s squared. What if I wanted to find a times, what if I wanted to find different variables? So I implanted variables everywhere in that integral, and that's your own cup of tea to find out how to solve that. That is going to be happy grammatics day there. I was really high that day. But yeah, this brings us the end of this solution. No, that's not the end of this solution. I think I'm gonna try talking fast. Okay, but that's not the end of this solution. Let me try and do my speed. But that's not the end of this solution. I remember I said that I'm going to do this thing. I'm going to attempt it using another integral. That's another solution to that video, but I wanted to attempt this question using another substitution. So I have let u equal to the square root of 3x plus 4. If we differentiate both sides, we have u is equal to 3x plus 4 to the power of half. First of all, you bring on the power, you have 1 over 2 times 3x plus 4 to the power of 1 and minus 1 over 2. Then the differential word inside, you have 3. So the u is equal to 3 over 2 times 1 over the square root of 3x plus 4 dx. So you have, instead of 1 over square root of 3x plus 4, you just have 1 over u. You have 1 over u. And instead of dx, you have u divided by 3 over 2. You have u divided by 3 over 2. Oh, let me just apply this here. You have dx. This implies that dx is equal to 2 root 3x plus 4 over 3 du. Okay, yeah, this is here to write down. So you have 1 over u times 2 over 3 root 3x plus 4 du. Okay, now this is actually a little bit hard to solve if I didn't just have insight now from God. But I saw you, I'm also seeing x here, so that actually it really hard to solve. But then I just remember that let u equal to this. So all this here is simply just u. And the u here will cancel out the u. So now you're left with the integral of 2 over 3 du. Now what's the integral of 2 over 3 du? That is simply just 2 over 3 times u. Now what is u? U is equal to the square root of 3x plus 4. So you get the exact same answer, 2 over 3 times the square root of 3x plus 4. So yeah, using those two methods, using those two integrals, you get the exact same answer. So yeah, let's move on to the next question. Like next week 5. Yeah, we're actually so close to finishing. I thought it actually take up 2 hours, but yeah, we're already in week 5. Week 5, I think this is week 5 question. So I think we are going to week 6 now. So. And just week 7. So I'm saying just week 7 as if I've created week 8 video. I'm not created week 8 video. I'm not even created week 9 video. But yeah, I'll create them as soon as I get a chance. Okay, I'm moving on to week 5, not week 6, but moving on to week 5. So week 5 says we should find the limit. Find the limit, let me just use shorthand. Limit of x as it tends to 0. So not the limit of x as it tends to 0, the limit of x power 4 minus 3x cubed plus 8x squared divided by x cubed minus 2x squared as x gets to 0. So as we find the limit of x power 4 minus 3x cubed plus 8x squared divided by x cubed minus 2x squared. Now, normally when you're given a limit question, you can just substitute what value of x here is into that function and you get the limit that you're looking for. But in this case, if you substitute what x is into this function, you will get something that mathematicians don't like. So this extra here, you get 0 divided by 0. I remember we don't like dividing by 0. It creates contradictions. So you cannot just input x as 0 into this function. What you have to do is actually to, I don't use the word manipulate, but it's actually just rearrange or restructure this function that we don't get that contradiction. And the one way I can say you can do that is if you multiply and divide both sides by x squared. Or in simpler terms, let's just factor out x squared from both sides. You factor out x squared from this side, from the numerator. You have x squared. X power 4 divided by x squared is x squared. Minus 3x cubed divided by x squared is minus 3x. Plus 8x squared divided by x squared is plus 8. All divided by, if you factor out x squared from the numerator, x cubed divided by x squared, that is x. And minus 2x squared divided by x squared, that is minus 2. So now if you notice, there's x squared in the numerator and there's x squared in the denominator. So I'll cancel those x squares. And you're left with x squared minus 3x plus 8 divided by x minus 2. If there was more that could be done, I would have done. But from here, if you notice, if you substitute x inside the numerator, you get minus 2 and you don't get 0. So here you can substitute x equals 0 now. 0 into here, you get 0. 0 into here, you get 0. 0 here, you get 0. So all you're left with just 8 divided by minus 2, which is equal to minus 4. Yay! So the limit of x power 4 minus 3x cubed plus 8x squared divided by x cubed minus 2x squared is simply just minus 4. But I just want to add, what does this limit imply? What this limit implies is that if you graph it, let me graph a random function. I don't really know what the function looks like, but let us graph a random function. Let's say something like this. This looks like the sine wave. Sine function. I'll graph something totally random. Go up, go down, go up, bend. Yeah. So you have a function like this. Totally random. So this actually looks like new. Add I here. Come out. What is the market? So yeah, you have a totally random function like this. What this implies is that as you are getting to this point, this limit, in this case you have 0. As you're getting to this point, that number, that limit that we got, minus 4, should be the y value. But in this case now, at when x equals 0, you have a break. That is, this function is discontinuous. It breaks at a point in time. But what this thing tells us to do is, even if at that point in time there's no value, because at x equals 0, that place it breaks. There's no value at that point in time. But when there's no value, what is that graph moving towards? If you notice, as it's moving towards this point, let's say this part here, as it's moving closer and closer to 0, it's getting closer and closer to that minus 4 that it breaks at. So when it breaks at minus 4, this function is getting closer and closer to that minus 4. Then the moment it gets to minus 4, it breaks, it becomes discontinuous, then it continues the other way. That's what that minus 4, that's what this means for. As that function is getting towards this, what is the as the number is getting, as x is getting towards the number, what is that function getting towards to? So yeah, as the independent variable is getting to a number, what is the function or dependent variable moving towards? Another way to solve this question, which is not really an efficient way, is to use smaller and smaller values. Like, let's say we're looking for the limit of let's say we're looking for the limit as s gets to, let's say, 16. So instead of using 16 here, we just say let x equal to 15.9. Then let x equals to 16.1. Then let x equals to 16. In fact, let's just try it. I'm not going to try it, but because I'm not my calculator. I can't really do that much technical work. I expect to finish this video on time. But I want to give it as work for you. You can try when x equals to, let's say, minus 1. Let's start with positive. Plus 1, then minus 1, then plus 0.5, then minus 0.5, then plus 0.1, then minus 0.1, then maybe plus 0.01 minus 0.01. What you notice that as x is getting closer and closer to 0, this function is getting closer and closer to minus 4. But let's start what this thing tells us to do. So yeah, that brings us end of this solution video. Not solution video, how I say solution video. That brings us end of this week. Let's move on to week 6. Before I continue, please let me send this link to the group, to all the groups I have again. Tell them that, yeah, started. Come and join. Well, then, I asked it to record the two in 720 pixel. Even though I put at 720 pixel, which takes more data, it's still graphically impaired. Oh, sorry. As I clear now that I'm not even talking down when I was talking. That's Steve. But it's not that I'm not talking. But I try to feel weird if I go back to the group again and tell them I should try the game. But yeah, I'll just continue. I'll finish up the video. So now we have 6. I'll start with 5. So we have week 6. The penultimate week. Week 6. Okay. Oh. Okay. Week 6 asks us to find the absolute extremas for the function. So we have a function f of x. This of x was never called y. We have a function y is equal to 5 over x power 4 minus 30 divided by x power 6. The marker now is turning back green again. Adding to the in. Okay. Y is equal to f5 divided by x power 4 minus 30 divided by x power 6. We should find the absolute extremas of the function over the interval 1 and 10. So basically, what this is we have a function. I'm going to clean this later. We have a function. Let's say something like this. You now give us a limit, the upper limit and the lower limit as 1 and 10. So now we should find the highest value. Let's call it here and the lowest value here. Now the thing is that don't just pick the highest number and 10 and then put the lowest number. I think that will give you your highest and lower value. No, your at this interval self, your graph can do something like this. You can do something like this. Where the highest point is not known at the intervals, and the lowest point is also known at intervals. But what this means is that at this point, the gradient or the tangent at this point, look at the tangent here. What means at the tangent here and here, they are all zero. That is dy dx is equal to 0. At this point, dy dx is equal to 0. At this point, dy dx is equal to 0. At this point, dy dx is equal to 0. At this point, dy dx is equal to 0. So by the time you differentiate and you equate that dy dx to 0 and get the value of x, that gives the point where you have 20 points. That gives the point where you have 20 points. 20 points. So what you have to do with that number now is pick the highest one. That is, once you have found 20 points, let's say here the value is x1, you find f of x1, you find f of x2, you find f of x3, f of x4, f of x5, and pick those 20 points. You don't have to compare which of them has the highest number, which of them have the lowest number. Once you have picked that one as the highest number, good and fine. Once you have picked that one as the lowest number, good and fine. But what if the graph is actually like this? The other you have picked these ones, you still have to now check what is f of the upper limit and f of the lower limit. That is, put in this 10 and 1 into the function and see what your value gives you. So now compare all of them that I've gotten, the derivatives and this limit number, to check which one gives you the highest number, which of them gives the lowest number, and that's going to be the answer. Let's do that. The next I'm going to do is to find the maximas at the critical point. That is, the critical point now is when we differentiate. You have the 20 point, sorry, you have the y dx is equal to, sorry, let's just start from y. Let's write y in terms of in this form. Let's write y in this form. You have y is equal to 5x power of minus 4 minus 30 x power of minus 6. If you differentiate both sides, we have dy dx is equal to minus 20 x to the power of minus 5 minus 180, sorry, plus 180 x power of minus 7. Don't forget, you bring the power down, you now raise the power, you now minus 1 from the power. You bring the power down, you minus 1 from the power. So now all you have here is dy dx is equal to minus 20 divided by x power of 5 plus 180 divided by x to the power of 7. Now what we're looking for is when dy dx is equal to 0. So we're looking for when this is equal to 0, what's the value of x? So if we multiply all through by x to the power of, let's say, x power of 7. Now if we multiply all through by x power of 7, we have minus 20 x squared over here plus 180 is equal to 0. That's x power of 7. So x power of 7 divided by x power of 5, that gives you x squared. So you have minus 20 x squared plus 180 divided by x power of 7 times x power of 7 just gives you 180. And 0 times x power of 7 just 0. So now you have minus 20x squared plus 180 is equal to 0. If you apply some mass here, you have 180 is equal to 20x squared. Divide both sides by 20, you have 9 is equal to x squared. If you square both sides, you have x is equal to plus or minus 3. So these are the two values of x that are turning points. That is that function that we got the first time. The 2 points where the thing turns is at plus 3 and minus 3. But remember, the interval they give us is 1 and 10. So this plus minus 3 is out of the interval. We're not going to consider it at all. So the only turning point that we have in this interval is just going to be plus 3. So we have plus 3. So these are going to be the three numbers we're going to test. That's first of all the turning point of the function and the intervals 1 and 10, the upper limit and the lower limit. These are going to be the 3 points that we're going to test. So now what's the x value? Let's find the y value. Because y value is going to determine the maximum, the limit, and the minimum. Like the y value, how much rises the y value and how much it goes down the x value. The x value, how much goes down, how much goes up in the y value, not the x value. So the x value doesn't matter. It's the y value that matter much. So you have y is equal to 5x power minus 4 minus 30x power minus 6. When x is equal to 1, this is equal to times 1, and this is equal to times 1. So all you have here is just 5 minus 30, which is equal to minus 25. when x is equal to 10, you have 5 times 10 to the power minus 4 minus 30 times 10 to the power minus 6. So this is equal to 5 divided by 10 to the power 4 minus 30 divided by 10 to the power 6. So this one is 5 10 to the power 6 times 500. 500 minus 30, that is equal to 470 divided by 10 to the power 6, which is equal to something like 4.7 divided by 10 to the power 4. So yeah, we go like 0.123447. 1, 2, 3, 4, 5. I think 4 minus 4. Sorry. 1, 2, 3, 4, 7. So yeah, we have 0.123, like 0.00047. Then the final one is when x is equal to 3. So you have y is equal to 5 times 3 to the power of, 5 divided by 3 to the power of 4. That's 5 divided by 3 to the power of 4 minus 30 divided by 3 to the power of 6. This is 3 to the power of 5 here, and you have 10. So if you multiply here by 3, you have 15 here, and you have 3 to the power of 5. So this is going to equal to 5 divided by 3 to the power of 5. And 3 to the power of 5 is what? 3 to the power of 5 is, it's 1 times 3, that is 240. So this is equal to 5 divided by 241. 241. 243. 1 times 3, that is, yeah, 243. So the first number I have is 47 divided by 10 to the power of all these. You have right. So now if you look at the lowest number here is negative number. So this is going to be a minimum value. And the highest number now is going to be this number. This number. Because now that 10 to the power of 6 is much bigger number than 443. So I know this number is going to be greater than this number. So you have the lowest number, the lowest number is this one, and the highest number is this one. So you can now put your answer. Now the question is, what is your maximum value and what's the minimum value? The maximum is at x equal to this was I think 3. At x equals to 3, y is equal to 5 over 243. Why the minimum is at x equal to 1, y is equal to minus 25. So this is your maximum and your minimum value. As well as let me confirm if I give any sneak peek or any information. Don't pass the phone, don't pass the phone, don't pass the phone, don't pass the phone, Jesus. uh, week 6. Okay. Okay, so I might take the second derivative. Okay, yeah, I start at that point of 3. Once you find the first derivative, you now take the second derivative to find out if it's the maximum value or minimum value. But I said in the video there is no point since we're already going to test the values, so I'm going to also include the extreme point. You know that the function was given to you at this thing, what they call it, at that is from infinity to negative infinity. No, it was given at a range, so you have to check this thing, what they call it, just you have to just pick the one that is like given to you. There's no need for you to check if it's maximum point. Okay, and that's that. Note the difference. The extreme values is f of a. That is just, it's going to be just the y values. Why the location of extreme is going to be the x values. Why the extreme point itself is going to be the x and y value. That's when you put your answer. You put the x and y value. So I put there that the maximum value is 5 divided by 243 at x equals to 3, which is what I wrote down there. And the absolute minimum value is minus 25 at x equals to 1, which is absolutely correct. In this video, I know how to put down what 5 divided by 243 was because I don't know it offhand. But in this solution that I have here, I can see that the value of 5 divided by 243 is actually 0.0206. I couldn't do that offhand, so I just did that in this video. But yeah, the value that I'm getting here is 0.0206. So that brings us to the end of this solution video. We can now go to the last solution for today. Well, the last solution for this video because I still want to do that live on TikTok. So the last solution for this video. So can I go on to the last question for this video? Question 7, says that we should perform the following derivatives, where a is a constant, which of the derivative is unusual compared to the others, show and explain why it's unusual. This one also says that we should differentiate a lot of functions. First of all, we should find, okay, the map is actually filling up now. I think I've opened it for too long. You put you on ease. It's more or less just to expose you to a lot under calculus. That is, there are a lot of things under the sun. So it's just expose you more and more to a lot of things that you may not have seen in your high school calculus. So that's basically what this competition is for. So it's very, very, very nice competition to get yourself into. So now we are told to differentiate 4 things. We should look at them, find out something that is different from them, and give a reason why that difference occurred. Now, the first part, they are more easier to differentiate and find out what is different. But give a reason why a difference occurred may be the tricky part. But no problem, that is what I am here for. Let's differentiate. The first one, or the first one I want to do is to have a due substitution. I'm seeing AX here, I'm seeing AX here, I'm seeing AX here, I'm seeing AX here. So it's wiser to just say, let U equal to AX. You differentiate this, you have du is equal to a dx. That means that dx is equal to du divided by a. If you put that here, the derivative of sine ax is equal to the derivative of ax, sorry, equals the derivative of sine ax du times du over dx. Okay, let me change it from dx equals to du. So du dx equal to a. Yeah, this is better. So instead of du equal to a dx, and instead of dx equals to du over a, I just put as form of du equals du divided by dx is equal to a. So we have the derivative of sine ax related to x is equal to the derivative of sine ax related to u times du dx. It's just chain rule. The same chain rule that we use as this video. The same chain rule that we are going to apply here. The derivative of sine ax, this ax here is just same as u. So we are just differentiating u. And with differentiate u, you have cos u. The u dx is same as a. So this times a. But don't forget what u is. U is equal to ax. So we have a cos ax Let me write it down. A plus A. Okay, you do that again. We have to differentiate respect to x, e to the power of ax. This is equal to the ax respect to du times du dx. If you differentiate e to the power of u, you get e to the power of u. If you differentiate u du dx, that's just a. So this is equal to a times e to the power of ax. The next question is differentiate the natural log of ax. You differentiate the natural log of ax with respect to x. This equals to the differential of the natural log of ax with respect to u times du dx. The natural log of ax is the natural log of u. You differentiate the natural log of u, you get 1 over u. But 1 over u is equal to what? 1 over ax times du dx is equal to a. So a cancels a here, you're also left with 1x, 1 over x. The final one is the derivative of respect to x of the square root of ax. This is equal to the derivative of respect of u respect to u times du dx. If we differentiate the square root of u, you get u to the power of half will become u to the power of minus 1 over 2 minus no half here. So that is going to become 1 over 2 square root of ax times a. So you have 1 over 2 square root of ax here times a. Yeah. So now, because of this, you look at this and pick out a different one from here. And already you can realize that there's a here, there's a here, there's a here. But there's no a here. So obviously this is going to be the different one. But now the third part of the question now is why does this difference occur? And does it break any form of mass? Well, no, it does not break any form of mass. Because remember that the natural log of ax is equal to natural log of a plus the natural log of x. Natural log of a here is a constant. So if you differentiate both sides, you are just left with the derivative of x. And the derivative of lim x is 1 over x. The derivative of lim a is also 0 because it's a constant. So it does not really break any form of mass. It just makes mass more beautiful, you understand? In it. Makes mass more sexy. So now you have lim x, derivative of lim ax. The a gets cancelled out because a is going to be constant if you represent that form. So even if you put this form, it still has that property that a is a constant. So yeah, get 1 over x. And that brings us to the end of this series or this part of the video or this part of the week. I've already solved 7 of the solution videos. I'm going to compile them and put them all on the channel so you can access them even after the live ends. And that brings us to the end of this session. See you in the next one. Oof. You hear about okay, how will you hear me? So bye. Bye bye.